Alright, so today we're going to be using, we're going to be finding the trigonometric functions of all angles, which is section 5.3. Now this is going to take us a couple of days to cover. So the first thing, let's think about coordinates. So this says let P equal 1, negative 3. So 1, negative 3, there's my coordinate. Be the terminal side of theta. So here's my angle. That was a really terrible drawing, sorry guys. Find each of the 6 trigonometric functions. So we're actually going to create a triangle out of this. Remember, trig is the study of triangles. We're going to be dealing a lot of triangles. So here's my right triangle here, and here's my theta. So I'm going to actually pull that off over here just so it's drawn a little bit better. Here you go, there's theta. This was 1, and this is negative 3. Now we do have to find that missing side, right? So let's use our a squared plus b squared, squared equals c squared. So we have 1 plus 9 is 10, and c squared, or sorry, c would be the square root of 10. So there's our hypotenuse. And now we can set up all of our trig functions. So sine is opposite over hypotenuse, negative 3 over root 10, which means the cosecant is the reciprocal. So root 10 over 3, and that's negative as well. Now this one's not rationalized, so we're going to go back and go ahead and rationalize that. So we got negative 3 root 10 over 10. All right, so there's my sine and my cosecant. Now let's do cosine. Cosine is adjacent over hypotenuse, so 1 over root 10. And again, I'm just going to go ahead and flip it and find secant real quick. So root 10 over 1. So secant was easy. Cosine, we do have to rationalize again, so we're going to do root 10 over root 10. So we get root 10 over 10. And last but not least, tangent is opposite over adjacent, negative 3 over 1 is negative 3, and cotangent is negative 1 over 3. All right, so those are our 6 functions if they gave us a coordinate, for a point. Now, understand this is what we just did, right? You didn't really need this for that lesson. But sine is opposite over hypotenuse. If you look in the picture, sine was opposite, which is my y-coordinate, negative 3, over hypotenuse, which was our radius, okay, So we have our x-coordinate, our y-coordinate, and our radius. And that's all this table is really telling you. You know, if it's your x-coordinate, your y-coordinate, or your radius. Which that's going to help you when it comes to your quadrantal angles. So these are called your quadrantal angles. And the reason they call them quadrantal is because they're the 4 quadrants, right? 0, if you're talking about 0 degrees, 0 degrees is right here. If you're talking about 90 degrees, 0, 90. All right, if you're talking about 180, 0, 90, 180, and 270 is the other one, 270. So those are just, you know, the 4 main, those are your quadrantal angles. So let's put this in terms of a unit, because we're going to be working a lot with something called a unit circle, which means this is just 1 unit long. So my coordinate for this point would be 1, 0. And the radius would be 1. So let's do, let's go ahead and find they want us to find cosine and cosecant. So cosine of theta is our x-coordinate over our radius. So our x-coordinate is 1 and our radius is 1. Our cosine at that point would be 1. Our cosecant is our radius over our y-coordinate. Our radius over our y-coordinate, which happens to be 0 here. Remember, we can't divide by 0, so that would be undefined. I'm not going to spell it out. All right, and you can find any of them. You can find sine, cosine, tangent, all the above. Here, again, we're going to use that unit. We're going to use that unit circle, so we're going to say our radius is 1. This coordinate would be 0, 1, right? 0, 1. And let's go ahead and find them again. Cosine of theta. Cosine, again, is x-coordinate over the radius, so x-coordinate over the radius, and 0 divided by 1 is 0. Now our cosecant is r over y. 1 over 1 is 1. Moving on. Here we've got our coordinate -1, 0, and our radius is still 1. We're just using that unit circle, which again, we're going to be working a lot with a unit circle. So here, cosine is x over r, which winds up being -1. Cosecant is r over y, which again is undefined. Can't divide by 0. And then, where'd my mark go? 270 is 0, -1, 0, -1. And my radius is still 1. So we're at cosine of theta is x-coordinate over the radius. So x-coordinate over the radius is 0. And our cosecant is our radius over our y-coordinate, which winds up being -1. All right, moving on. So in the 4 quadrants, your trig functions, we're going to talk about the signs of the trig functions. And a nice way to, well, this is kind of telling you, so in quadrant 1, all your functions are positive, because think about your coordinates. Your x-coordinate is positive, your y-coordinate is positive, everything's going to be positive. Here, your x-coordinate is negative, but your y-coordinate is positive. So sine and cosecant, because they go together, sine and cosecant are going to be positive here because they are related to your y-coordinate. Here, we've got negative, negative. So negative, negative, a cosine divided by a sine, a negative divided by a negative is going to get you a positive tangent or cotangent. And then here you've got your cosine and your secant because you're positive, negative, your y-coordinate, which relates to cosine. Again, we're going to learn that. And cosine goes with secant. So those are going to be positive here. A good way to remember this, because you don't always have this, it's A, S, T, C. All students take calculus. All students take calculus. So just if you want to remember which ones are positive, just remember all students take calculus. So here, all of them. Here's sine and cosecant. Here, tangent and cotangent. And here, cosine and secant. So here, this is just figuring out which quadrant you're in. So we're here. It says sine of theta is less than 0. So we want sine to be negative. Well, sine is negative in quadrant 3 and quadrant 4. Here it says cosine is less than 0, so cosine is negative. Cosine is negative in quadrant 2 and quadrant 3. So quadrant 2 and quadrant 3, here's where they both conditions are met. So we're in quadrant 3. So you just got to figure out which ones you're working in. All right, example 4. So in this one, we're going to go ahead and draw this out real quick. We're going to draw this out. So it did say, so here our tangent is negative. Remember, A, S, T, C, all students take calc. Tangent is negative. Let's see, this quadrant 2, and quadrant 4. It also says cosine is negative. Cosine is negative in quadrant 2 and quadrant 3. So we're in quadrant 2. So it's very important to find out what quadrant you're in. So here's my angle. It doesn't really matter where we're at right now. Here's my theta. And we're going to go ahead and drop it down. So now you know tangent is opposite over adjacent. Opposite is 1, adjacent is 3. Now the negative goes with what quadrant we're in. It's a -3 and a +1. Okay, opposite over adjacent. Now we can use Pythagorean theorem. A squared plus b squared equals c squared, and we're going to find that missing thing, or that missing hypotenuse thing. So here, 1 and 9 makes 10, and we want the square root of 10. It's the same as the one before. And now they want us to find sine. Sine is opposite over hypotenuse. So opposite over hypotenuse. And yes, we do have to rationalize. So root 10 over root 10. We're going to multiply, and we get root 10 over 10. So there's my sine. Secant. Remember, secant goes with cosine. Cosine of theta. So cosine is adjacent over hypotenuse, so this will be hypotenuse over adjacent. Hypotenuse over adjacent. So it's negative root 10 over 3. All right, moving on. Now reference angles. So we're going to take a minute on reference angles. A reference angle, I lied. I'm going to make a part 2 to this video because I don't think I'm going to be able to finish these 2 examples. So I'm going to do a second part.